Okay, so for this video, we're wanting to graph an equation. But for this video, we don't have some background. We know what a quadratic is, but we don't know the shape of a quadratic. We don't know that this is just, later in the course, we'll know this is just a bowl, and then the transformation on this bowl is that it's been shifted down by 10. At this point, all we really have is what is a function, what isn't a function, and what is a polynomial, what is a polynomial. This is a degree 2 polynomial. So to try to graph this without a calculator, and then with a calculator, and then we'll do the Pearson online homework system. We'll try to use that tool and figure out how to input this into the Pearson online system. But at this point, all we can really do is make a table and take a look at points. And so when I look at this, I have an input and I have an output. I have a domain and I have a range. My input, and that's going to be my x values. And my output, those are my y values, which are the same thing as my f of x values, right? Those are my function outputs. Terrible column for a table. There we go. Because I know that this thing's a bowl, and I know that it's symmetric about 0, whenever I choose a point to the left of the axis, on the left of the y-axis, I'm going to choose that same point to the right of the y-axis, and you'll see why here in just a minute. So I'm going to choose, I'm going to graph this with 5 points. I'm going to choose the points -2, -1, 0, 1, and 2. We may tack a couple more on at the end, just as we want to see a little bit more here. But when I run that's going to be -2, that'll be f of -2. And that's going to be the same thing as -2 squared minus 10, which will be what? -2 squared is 4, so that'll be 4 minus 10 is -6. Okay? Now f of -1, that's going to be -1 squared minus 10. That's going to be 1 minus 10. That's going to be -9. F of 0, that's going to be 0 squared minus 10 is going to be 0 minus 10 is going to be -10, right? Makes sense. At 0, I'm going to be at the vertex of this parabola, at the bottom of that bowl. And so 0 minus my offset is just going to be the offset. And then, kind of going back up the other side of the bowl, going back up the other side of the offset, I'm going to have f of 1. Well, that's going to be 1 squared minus 10, which is just going to be 1 minus 10, which is going to look eerily familiar. -9. All right, same thing with 2. And you'll see because of this square, the negatives went away earlier, and the negatives aren't there now. And so what are we getting? We're getting the same values out over here on the right side of the y-axis that we got on the left side of the y-axis. And that's what I meant earlier when I said this thing is symmetrical about that y-axis. And it's a property of this x squared function. It's because of the even power, the power of 2, and then the negatives are going away. All right, well, what that means is that I now have 5 ordered pairs, right? What I've just done with this table, I've created 5 ordered pairs. I have P1 is -2, -6. I have P2, that's -1, -9. I have P3, I have 0, -10. P4, -1, -9. And P5, that's -2, -6. And now I want to sketch that. Okay, I'm going to cheat a little bit here. I'm going to try to make my axes a little bit nicer. I am also going to cheat a little bit and taking a look at my x values are symmetric about that y-axis. I chose that, and that's why it's the independent axis. The x-axis is the independent axis because I got to choose those values. The y value is the dependent axis because those values depend on the function's impact, the function's work on those x values. And as I look at the y values, they're all negative, right? And so because of that, I'm going to cheat a little bit here, and I'm going to place my horizontal axis. I'm going to try to keep the same length on either side of the y-axis, but I'm going to definitely cheat towards the negative side as far as what we see. Okay, and so I know I'm going to have values at 0, 1, and 2. I have values at 0, -1, and -2. Ooh, that grid is starting to grow on me. I'm not sure that was better. We'll find out. And I've got to go all the way down to -10. So 1, 2, 3, 4, 6, 7, 8, 9, 10. And so I got a point at 0 and a point and -10. So that was my P3, right? That's my P3. And then when I went to -1, I went down to -9. So I got a point right there. And then when I went over to 1, I went up to -9. So I also have a point there. Those are my points 2 and 4. And then my point at -2, well, it was down at -6. So 1, 2, 3, 4, 5, 6. There's my -6. And so my -2 is going to be about there. And my 2 is going to be about there. And you can start to see there's an acceleration to this. Now I'm gonna do a little bit more just for the sake of putting these dots in, so we can start to see the shape a little bit better before I run to the calculator. If I do -3 and 3, so if I do -3, it'll be f of -3. All right, so what's that going to be? -3 squared minus 10 will be 9 minus 10 will be -1, and then 3. Well, we've got this symmetry, right? We know that's also going to be -1 because it's going to be 3 squared minus 10 gives me 9 minus 10. Okay, so now when I go back to -3, I know I'm going to be, well, that grid's getting way too big. Way too large and friendly on the left-hand side there. So let's erase that and bring that in just a touch. All right, so now I got a point about there and a point about there. And I can really, I've done a better job graphing this on the right-hand side. I can start to see this curvature, this parabola, as it comes up and then passes through and goes on for forever. And forgive the bad graph here. We'll kind of shift that over a little bit, plus or minus a rough graph. And an inaccurate grid. This is roughly the shape of a parabola, the sketch of a parabola. Okay, now let's go to the calculator and let the machine do it, because what the machine's going to do is, rather than pick 5 points or 7 points, the machine's going to pick 100 points or 1,000 points and make the graph look a lot better, and the machine's going to be able to keep the grid a little more consistent than I was able to by hand. So I'm going to hit the y equals button, this upper left button on my calculator, and I'm going to clear out whatever function we've been doing before here. And I'm literally just going to type in, so this y0 of x, that's my f of x. F of x equals, and so what I'm really wanting to put in here is the right-hand side of the equation. And so that's just going to be the right-hand side of the equation I was given up here. And so that'll be my x, and that's my variable button, and that's that xt theta n button. It's immediately next to that pale yellow alpha button. I'm going to press that x button, and that's going to give me a variable. And I can either use -2, which would be this button under clear here, next to tan, under clear, there's this up arrow in white that I could hit and then press the number 2. Or I can hit the x squared button, which is above the log button and below the x to the -1 button. And so if I hit the x squared button, I now have x squared. And then I do -10 and hit enter. Now, before I go on, I'm going to hit window. And -10 to 10 is a good window to just try, a good standard window to try. And so when I hit graph, I'm going to see that I have a bowl. And that bowl, if we spread this out a little bit, that bowl, it goes down to -10. And where it passes through the x-axis, looks like it's a little bit to the right of 3 and a little bit to the left of -3. And so this looks really, really similar to what I sketched. This is just a much prettier version of it. One thing you really have to pay attention to when you're graphing, though, is that because I told you to go from -10 to 10, and then I didn't give it a square physical window to graph in, right? This is a rectangle that it's graphing into. The aspect ratio of this is not 1-to-1. The scale of the x-axis is different than the scale of the y-axis. You can see that in the boxes on the grid. And so maybe a better visual of what's going on here could be achieved by changing my scales a little bit. Now you see how those boxes in my grid are more like squares. And so that's going to give you a better feel for the relationships of this parabola. Our calculators, they can deceive us, and part of that's because the window that our calculators actually gives us is not a square, but we very often use square windows when we're plotting, and so one axis actually covers more distance than the other. All right, now let's switch over to Pearson. Let's switch over to my math lab, because this is the way they ask the question. And this is a little bit daunting when you look at it. The best thing to do when you're trying to put the input in here, and I'm on my iPad here, so it may look a little bit different on a machine, on a desktop. But if I hit this click to enlarge graph button, so use the graphing tool to graph the equation, click to enlarge graph. I click on that, and it pulls this window up. Now, I know that this is an x squared. I know that's a degree 2 polynomial. I know that's a bowl. I know that's a parabola. And so when I'm choosing which tool to use here, and I don't know if it's going to let me hover over on this or not. No, it's not. If I took a mouse, hey, maybe, hey, I got a Bluetooth mouse on this thing. If I took a mouse and I hover over that, I think it's going to give me a name. Oh, well. That tool right here is their 3-point parabola tool, is what they name this. And so I want to click on that 3-point parabola tool, and then I want to choose 3 ordered pairs. Well, one of my ordered pairs was that 0, -10. And so I'm going to choose that point. Another ordered pair was 1 over and 1 up from that 0, -10. And then one of my other ordered pairs was 1 back and 1 up from that. And so that's my 3-point parabola. And take a look. If this is 2, 3, 4, it's crossing the axis a little to the right of 3, a little to the left of -3. This looks a lot like, and okay, if I'm checking my points, my point that was over 2, it was up at -6, right? Because I had that point at 2, -6, and -2, -6, right? And then I had the point at 3, -1, and I had the point at -3, -1. So this is the same parabola that I got by my points earlier. It's the same parabola I got by my graphing calculator. This is just how we enter it into my math lab for Pearson. I am sorry that's a little confusing, but I still think they overall do a good job. But I do agree that that's a little confusing, and you have to know a little bit about their tools to be able to give the answer. All right, I hope that helps.